All right, so today we're going to be looking at some revision for probability before our CAT tomorrow. I'll post some more details about how that's going to run, so keep an eye out for that. But yeah, today these are questions that you guys have asked me to go through, so hopefully that'll help. You can feel free to fill in the gaps on your own worksheet. You can skip through questions if you already get them. Yeah, we'll go from there. So I'm going to get a highlighter out to go through my questions to highlight key parts. The first question here is question 9, and it's from the practice test of probability. So you have a group of 12 friends that are sat at the table. 4 of them order soup, or both soup and salad. 2 have neither, and 3 order soup only. It says show the information on a Venn diagram. So the first thing I would do here, okay, show a Venn diagram, we need to make sure we put it in a rectangle. We have 2 options, soup or salad, so we're going to put 2 circles and label them soup and salad. Okay, now I'll grab another colour. Now remember, every time you do Venn diagrams, okay, look at the intersection first. What are you going to put in this middle part? Okay, so how many of them like both? Well, when we highlighted before, there was 4 of them that liked both. Okay, so the number 4 is going to go in the middle. Then the next bit of information, we've got 2 ordered neither, so the number 2 is going to go on the outside. And then 3 ordered soup only. Okay, so because it has that wording of soup only, we can actually put that 3 here because this section of the soup part, okay, is soup only. So that's fine. Now we need to make sure that we account for 12 people in total. Okay, so we need to add up our numbers. So 3 plus 4 plus 2 gives us 9. So that means we still have 3 people that we haven't accounted for. Okay, so that 3 must be going in here. Yeah. So that's A. And then B says, if a friend is picked at random, what is the probability that the person chose a salad? So we found that 3 people like salad here, but don't forget, it just says chose a salad, so they could have chosen a salad only, or they could have chosen a soup and a salad, because that includes salad. So you need to make sure you account for the whole circle of salad. How many chose salad? 4 plus 3 is 7. So the probability of salad equals 7 out of how many people altogether? 12. Okay, that's your answer for that one. Moving on. So this is question 10 from your practice test of probability. Again, get your highlighter. So it says, using the information in the table below, if one young adult is chosen at random, find the probability. Okay, so we're choosing a random adult, there's a table below, and this is it. So we're looking at transport owned by young people. So the options here are, let me do some different colours. They either have a car or they don't have a car. Or the other option is they either have a bicycle or they don't have a bicycle. Okay, so A says a car and a bicycle. So they have both. Okay, so we want to look at this column here because they have a car. And we want to look at this row because they also have a bicycle. So what number did these ones match up? Here, the 30. Okay. So for A, there is, so the probability of a car and a bicycle, remember that upside down U means intersection. So the probability that they have a car and a bicycle is 30. Okay, because we found that number. out of the total. So what we need to do to find the total of people, we need to add up our rows and columns. So I'm just going to get rid of some of this. 30 plus 5 is 35. 8 plus 7 is 15. So that gives us 50 people. And then you can just double check by also adding up your columns. So we've got 30 plus 8, which is 38, and 5 plus 7, which is 12. That also does equal 50. Okay, so we know that there are 50 people accounted for. So 30 out of 50 people. And if we simplify this fraction, get rid of the zeros, okay, the probability is going to be 3/5. So the main thing here is being able to read the table and what do the numbers mean. So for B, it says, what's the probability of a car or a bicycle or both? Okay. With that kind of wording, it's asking you to find the union. That's the definition of the union between two things is, the probability of the car, the bicycle, or both. So what that does is, let me highlight, go blue. If you're trying to find the union, that includes, you want both, the probability of both, and the car only and the bike only. So you want to add up those three numbers from your table. So adding those up, you get 30 plus 5 is 35 plus 8, which is 43. And that is out of 50. We can't simplify that anymore, so that's your answer. Okay, so it's important that you remember, so look at these blue highlighted bits, okay, if you're trying to find the union, okay, which is this question, car, bicycle, or both, you need to include those three numbers. Okay, question 11. Another Venn diagram. Get your highlighter out. In the Year 9 elective program, there are 30 students who can choose from art, drama, and music. There are 4 students who chose all 3 subjects, 7 students who chose music and drama. There are 11 students who chose art and drama, 5 students who chose art and music, and 17 students in total who chose art. And there are 16 who chose music and 16 who chose drama. See, with this last sentence, it's interesting that it says 17 students in total who chose art. Okay. And who chose music, who chose drama. So that's quite important. All right, first thing for A, we need to complete a Venn diagram. The difference with this one is that art, drama, and music, there are 3 different options, so you need to draw 3 different circles. And the fact that there are 4 students who chose all 3 subjects, that means all 3 of my circles need to overlap each other. So it's going to look like this. You've got 1, 2, and 3. Okay, and we're going to put, this one can be art, this one can be drama, and this one can be music. And remember, they always need to be in a rectangle. All right, let's change colour. So remember, with Venn diagrams, you want to start from the middle and work your way out. So for this one, we know that we've got 4 students who chose all 3 subjects. So the number 4 is going to go in the middle here. Okay. Now the next one, 7 students chose music and drama. Okay. So looking at music and drama, the overlap, we're looking at this section here. Music and drama. Okay. So 7 people chose both of those. However, you need to account for the 4 in the middle here, because these 4 chose drama and music, but they did also choose art. But because they chose music and drama, we needed minus those 4 from the 7. So the number 3 should go here. Okay, because we can see that there are 7 people that chose music and drama. Okay, it's just separated. So let me get rid of that. Oopsie. Undo. Sorry guys, here we go. Let's get our circle back. Okay, so far we've got that one done and we've done that one. Okay, we're up to the next one. There are 11 students who chose art and drama. So same as before, 11 chose art and drama. We've already accounted for the 4 in the middle. Okay, so we need to do 11 minus 4, which would be 7. Okay, so there's 7 there. So this one still makes sense. 11 chose art and drama, okay, because 7 chose art and drama by itself and 4 people chose art and drama with music. So altogether, 11 people are doing music and drama, art and drama. Okay, the next one, 5 students who chose art and music. Okay, doing the same thing again. You've already got your 4 in the middle, so there needs to be 1 here to make 5. Okay, there are 17 students in total who chose art. Okay, so our circle for art needs to add up to 17. So if you add 7 plus 1 plus 8, that gives you 12. So that means we need 5 more to make sure that that whole circle adds to 17. Okay. 16 chose music. So this whole circle for music needs to add up to 16. So we've got 1 plus 4 plus 3, which is 8. So that means 8 goes here. And 16 who chose drama. So you've got 7. This whole circle needs to add up to 16. And you've got 7 plus 4 plus 3 is 14. So that means there must be 2. Are we done yet? Well, we have ticked all those off, but you always have to come back to, have we accounted for 30 students? So make sure you add up all your numbers. So 5 plus 7 is 12, 14, 17, 21, 22 plus 8 is 30. Yeah, perfect. So we know that there's no numbers that have to go on the outside. So we've done A. B, I'll pop that in pink. This is A, B. It says, if a student is picked at random, find the probability that the student chose art and music. Okay, so the probability that they chose art and music. Okay, so you can either get that from the information up here or your Venn diagram, but art and music, we know that 5 students chose art and music. Okay, so 5 out of 30, which is the same as 1/6 if you simplify it on your calculator. Next one, it says find the probability that they did not choose drama. Did not choose drama. Remember, so the probability that they did not choose drama, if you put a little dash here, that means not drama. Okay, remember that complement events that we looked at? So the probability that someone did not choose drama. So what we're going to do is count the numbers that are not in this big circle of drama. Okay, so you've got 5, 1, and 8. Let's see here. 5, 1, and 8. They're all the people that didn't choose drama at all. So that would give you 14. So 14 out of 30. Simplify that, it should give you 7 over 15. And number 3 says chose only one class. probability of only one class equals. So only one class, let's grab a different colour. So 5 people chose only art, so they only chose one subject or one elective. We've got these 2 that only chose drama as their elective, and we've got these 8 people that only chose music. So we're looking for these people chose only one class to do. So we add them up. 8 plus 2 is 10 plus 5, so you've got 15 out of 30. That simplifies to a half. So half the students chose only one elective to do. Okay, that's why it's really important to have this Venn diagram, because it's really easy to find all your numbers. Okay. Now, we've got independent events worksheet. So that was a worksheet we did, I think it was last week. But we need to know the difference between independent and dependent. Okay. So we've got 3 different ones here. So we've got 2 different people opening their books to the exact same page as each other. Okay. So with this one, we need to see if the second event depends on the first one. So our 2 events is, let's say Brandon is going to open his book to a certain page number. Oops, I spelled Brandon wrong. Sorry. Okay. Let's say Brandon opens his book up and it lands on page 46. Okay. When Ashton opens up his book, okay, doesn't matter that Brandon had opened his up to 46. So is the result of what page Ashton opens his book to, does that depend on what Brandon opened his book to? No, it doesn't. It's completely random. They're different books, so it's not going to really make a difference. Brandon opened up his book to a page, Ashton will open up his book, and they don't depend on each other. Okay, so that means they are independent events. They don't depend on each other. So that's an independent event. Okay, for this one. 2 different people opening their books to the exact same page. They're independent. I spelled this wrong again. Independent. Okay, let's go with number 2. Oops. So we've got 2 sheep giving birth to lambs on the same day. Okay, so we've got lamb 1. They have a baby, a little lamb. Sorry, sheep. Sheep 1 has a lamb. Gives birth to a lamb on the same day. So has a little lamb. When the second sheep has its baby on the same day, does it depend on the first birth of whether they give birth? So that's a bit hard. So you've got a sheep, they have their baby. Is that dependent on, does that second sheep depend on the first one? So if the first one didn't have their baby that day, does that mean that the other sheep won't have their baby that day? Okay, it sounds a little bit silly, but no, they're independent. Okay, that doesn't really matter. The fact that one sheep had a baby one day doesn't mean that that's why that second one had it on that day. Okay, it's just a coincidence. It's just random. What would depend on if they both conceived on the same day, that might matter. But for this case, they are independent. Independent. Okay, last one. Let's go green. Number 3. So, guessing who will finish in the first 2 places of a race. So the first 2 places is first and the next one is second. Okay, so if you're guessing, let's say I'm going to guess Cameron came first and Ewan came second. Okay. If Ewan came second, does that depend on the fact that Cameron came first? Okay. Well, yes, it does. Okay. Because it depends, whoever comes first, that means they're not going to come second next. Okay. So it depends who comes first will tell you who's going to come second. So when you're getting a place in a race, it does depend on each other. Okay. Because once you get first, that's it. And that will make the second place dependent. So that means this one's dependent. Okay, it's a bit tricky, but you've just got to think of that second event. Okay, does the outcome or the probability of that second event depend on what happened in the first place? That's what that one means. And this is our last one. Okay. And I'll get my highlighter. So we've got 10 students who completed a special flying course. Whoa. Special flying course. I need to get rid of my notifications. Sorry, guys. Are waiting to see if they will be awarded the one distinction or the one merit award available for their efforts. So A says, in how many ways can the two awards be given? Okay, if the same student can, that shouldn't be there because it's the question of the next one. Okay, so you've got 10 students that have done a flying course. They can either get a distinction award or a merit award. Okay, so this one is asking, okay, A, in how many ways can the two awards be given if the same student can receive both awards? Okay, so 2 awards are given. What I'm going to do here is make a table. So the first award can either be a distinction or a merit award. Okay, and then a second award's given, second award. And again, the options are you could get a distinction or a merit award. Okay, now draw up your table. One across there. Okay, so you could either get a distinction and a distinction award, or you could get a distinction and then merit, you could get a merit and a distinction, or you could get a merit and then a merit award. Okay, so the I part says how many ways can the same student receive both awards? Okay, well, you can either get a distinction and a distinction, or you can get a merit and a merit. So there are 2 different ways that you could get both awards. And II is how many ways could the same student cannot receive both awards. Okay, so that means they get one of each. So they could get a merit and a distinction, or a distinction and a merit. So there's 2 ways there that they cannot get both the same. Okay, B says, assuming a student cannot receive both awards, find the probability that a particular student receives. So, with this one, what would we do? Find the probability that they receive the distinction award. Okay, for this one, we're going to actually want whether they get a distinction or not. So we're going to do another table. So this was just a table to show sample space. But now we're going to do one to show probabilities, which is our 2-way table. Okay, so you can either get a distinction award or you don't get a distinction award. And you can either get a merit award or not a merit award. So do up your table here. Oops. Okay. So, assuming that a student cannot receive both awards, so they can't get a distinction and then another distinction, find the probability that a student receives the distinction award. Okay, they cannot receive both, so we're going to put a little cross through there because that would mean they get a distinction and a merit. Okay. They might get a distinction award here and not a merit, so that's half a chance, isn't it? Okay, because there's only 2 different awards you could get. And we're doing I for the distinction award. And what's the probability of them getting nothing? Cannot receive both awards, so there is a probability there. Over here, so distinction, not distinction, but you get a merit. So if you're going to get the merit first, it's going to be half. Okay, so getting the distinction award, here, distinction, you're going to have half. Okay, the probability is a half. Then we've got the merit award, so that's a half as well. Neither award, okay, so the probability of getting not a merit and then not a distinction one, okay, that means you actually need to go a half times a half. Okay, so to not get a merit is half times a half, so that's a quarter. So there's a quarter chance of getting neither award. Assuming that they can receive both awards, find the probability that they receive at least one award. Interesting. That they receive at least one award. So, well, we know that the probability of getting neither award is a quarter. Okay, so at least getting one, what you can do is go 1 minus a quarter, which gives you 3/4. So the probability that they can get both and receiving at least one is going to be 3/4.